This is lesson 2.4, synthetic division. Here's the setup for synthetic division. You might want to copy this down in your notes or take the time to get familiar with the setup. So we'll have the root. So I'll be writing the root over here. Then we'll line up all the coefficients in this line. We'll move the first coefficient down to here, and we'll follow this pattern of multiplying the first term by the root, then this term by the root, then this term by the root, and this term by the root. Here's the general setup, and it'll hopefully make more sense once we go through some examples with this. Here's an example for synthetic division. We'll find the root here as x minus 3. We can set that equal to 0. And when this is set to 0, we know that x, if we set it to 3, will equal 0, as 3 minus 3 equals 0. So I'll write it off to the side that the root is equal to 3. So now I can put it here in this corner, and then we'll take the coefficient of each of these x terms, starting with the highest degree. So the coefficient is 2, so I'll write 2 here. However, there's a gap here between the 5 and the 3 term. We're missing x to the power of 4. So in this case, we'll put a 0. So write 0 here as a placeholder coefficient. Then for the third term, the coefficient is negative 14. I'll write that down here. Again, we're missing x to the power of 2, so I'll put a 0 here for placeholder. X to the power of 1, or just x, the coefficient is positive 24. And x to the power of 0, or just no x, there's also a 0 here, so I'll have to have a placeholder at the end as well. Remember from the original setup, we'll bring this first term down here, so we have 2. Then we'll multiply this 2, the first term, by the root. So 2 times 3 is 6. 0 plus 6 is 6. Then we'll take this term and multiply it by the root. 6 times 3 is 18. Let's draw a line here. 18 plus negative 14 is 4. 4 times the root, 4 times 3 is 12. 12 plus 0 is 12. 12 times the root, which is 3, is 12 times 3 equals 36. 36 plus 24 is 60. 60 times the root, 60 times 3 is 180. 180 plus 0 is 180. So this is your last term, and so whatever you get in this last row, in this last column, is going to be your remainder. And when you have a remainder, you're going to add the remainder onto the end by putting it over what we're dividing by. And remember that we're dividing by x minus 3. So now that we finished this, we can rewrite it. Remember that our highest degree was x to the power of 5. So our highest degree now, since we're dividing, remember when we divide an exponent, by anything, we're subtracting it when they have the same base. So we have x to the power of 5 here, divided by x to the power of 1. So we'll be left with x to the power of 4 as our highest degree. So we'll take all these coefficients here that we found and move it in that order. So we have 2x to the power of 4 plus 6x to the power of 3 plus 4x to the power of 2 plus 12x plus 60 plus this remainder, 180 over x minus 3, because that's what we were originally dividing by. We'll go through some other examples so we can become more familiar with this. To find the root, we'll set this equal to 0. X minus 2 equals 0. The value of x that would make that statement true is 2. So we're going to write our root here. Then we're going to line up our coefficients. There's a 1 here in front of the x squared. So 1. This is negative 7 and negative 6. We're going to bring the first term down. As 1. Now, the first term times the root. 1 times 2 is 2. 2 plus negative 7 is negative 5. Negative 5 times the root is negative 5 times 10. Sorry, negative 5 times 2, which equals negative 10. Negative 10 plus negative 6 equals negative 16. And our highest degree was 2, so now our highest degree is 1. So we can rewrite this as 1x. Let's write it down here. We have 1x minus 5 plus negative 16 over x minus 2. And of course you can always write 1x as just x. Another example, to find the root, we'll set this equal to 0. The statement x plus 1 equals 0 becomes true if x equals negative 1. So write the root on this side. Then we'll bring down the coefficients. Coefficient of the first term is 4. The second term is 5. The last term is 8. We'll bring down the first term, 4, and multiply it by the root. 4 times the root, 4 times negative 1, negative 4. Adding these two together, we get 1. 1 times the root is negative 1. Adding it together, we get 7. 7 is our remainder. So we'll have 4x plus 1 plus 7 over x plus 1. Let's work out another example. In order for this statement to be true, x has to be equal to negative 4. Because negative 4 plus 4 does equal 0. We'll bring down the coefficients. 1, the coefficient stated is 0, negative 14, and 8. We'll bring down the first term, 1. 1 times the root is negative 4. Adding these together, we get negative 4. Negative 4 times the root is 16. Add those together, we get positive 2. Positive 2 times the root is negative 8. Adding these together, we get 0. This time, we don't have a remainder, so we won't have to add anything to the end. Our highest power was x to the power of 3, so now we'll just have x to the power of 2. 1 times x to the power of 2 minus 4, this is a negative, minus 4 times x plus 2. And because there's no remainder, we won't need to add it to the end. For the last example, we'll notice that we're missing a term between x to the power of 2 and no x. So we'll fill that in with a 0. The root is negative 4. The first coefficient is 1. Now the replacement coefficient is always just going to be equal to 0. See how there's no term for x to the power of 1. Bring the 10 down. First term goes down to the bottom. 1 times the root, negative 4. Adding these together, we get negative 4. Negative 4 times the root is 16. 16 plus 10 is 26. We do have a remainder here, so we'll have to add something to the end. 1x minus 4 plus 26 over x plus 4. Now we're going to factor each polynomial by checking the given possible roots, so given to us here. We'll talk more about possible roots in the next video. But first, we'll just go through the roots they've given us. If it helps to not skip missing terms, we can always rewrite these equations to include them with zeros as placeholders. So we go from 3 to 1, so we're missing x to the power of 2. So the 0 placeholder minus 20x minus 16. They're the same equation, but it makes it easier to see when we set up the synthetic division. Now for the possible roots, they're listed here, so we can pick one from here. We have plus minus 1, positive or negative 2, positive or negative 4, positive or negative 8, and positive or negative 16. If I choose one at random, I'll pick negative 2. We can set it up using the same method as before. So negative 2, the first coefficient is 1, 5, 0, negative 20, and negative 16. We'll move the first one down to 1 and continue through synthetic division. 1 times the root, 3 times the root, negative 6 times the root, negative 8 times the root is 16. So in this case, we got a 0 at the end, meaning there's no remainder. So negative 2 is a root, which means that x plus 2 is a factor. So we can continue down the line until we've gone through all the equations. So we can pick another number here. I'll just list them on the side. We've tried negative 2, and negative 2 works. This time we'll try positive 2. So we're going to put positive 2 in this spot here, and we're going to use these numbers to continue on. We bring down the first term, which is 1. And continue. 1 times the root, 5, 10, 4, 8, and 0. Here we have another 0, which means that 2 is a root and x minus 2 is a factor. So 2 worked. Now from the list of possible roots, we've done both positive and negative 2, so let's just move down the line and choose negative 4. Negative 4 on this side, negative 4 over here. Bring the first term down, 1. 1 times the root, negative 4, 1. 1 times the root, negative 4, is equal to 0. So we have another 0, which is another factor. So negative 4 worked. So now we know that x plus 4 is a factor of this expression. And negative 4 works. So this column here shows the progression of the highest power. We started out with x to the power 4, but as we move down each row, it decreases. So this is x to the power of 3, move down x to the power of 2, and finally we're just left with x. So we have 1x, and now we have 1. This remainder shows that x plus 1 is a factor. So if x plus 1 is a factor, that means that another possible root would have been negative 1. Since we were asked to factor each polynomial, we can just add up all the factors that we found into a final statement. So f of x equals x plus 1 times x plus 2 times x minus 2 times x minus 4. So this statement factored out is equal to this statement.